My expectation is for you to pay attention and ask questions today when you do not understand. We're going to go over examples like you weren't here Friday, because many of you were here in body.
I don't remember what we did.
And that would be it. There we go, for example. Okay? So we're going to go back over what we learned. And then I'm going to give you an additional worksheet for practice tonight. Okay. So let's start with the basics. Friday we talked about how to find a confidence interval. And to find the confidence interval, it's the sample mean plus or minus the margin of error. And you've probably read data, like when you look at polling information, it'll say so-and-so is currently in the lead with 51% with a margin of error, or plus or minus 3%. And that is your margin of error. So that's what we're looking at today, how to calculate that, the sample mean and the margin of error. So the margin of error is made up of two parts. The first part is Z star, and that's the Z-score that's associated with the level of confidence. And when we learned how to find this on Friday, like if we had a 90% confidence at level, this Z-star is that upper bound there. And so if this is 90%, that leaves 10%, so 5 is here, and 5 is here. So it's a probability of 95%. Now, what you need is the Z-score. That is not the inside of the chart. That is the outside of the chart. So you're reading the chart backwards. You have the probability. You want to find the Z-score that goes with it. And so it's that Z-star times the standard deviation of the sample, which we find by doing sigma over the square root of n. Now, this first one, do you see they gave us the margin of error? When they give it to you, you don't have to calculate it. You don't have to plug anything in here. Okay, so you're given the margin of error. You're also given the mean lifetime of these tropical fish. And it tells us there's 75 in this sample. Well, that's a good number. If the number in the sample is greater than 30, then we have a good sample, especially if it was a representative random sample. What is a 95% confidence interval for the lifetime of the African cichlids?
Cicadas.
Of the African
Fish,
tropical fish.
tropical
Cicadas.
fish. Okay, so the 95% confidence interval. We were already given the mean. The mean is 5.2.
Chichilids.
Oh my god.
And that is plus or minus the margin of error.
We're recording, so.
Now, we can do calculations to find the margin of error, but they gave it to us, so we don't need to. The only issue with this one is the mean was in years and the margin of error is in days, so we just do a little conversion from days to years. How many days are in a year? 365. So if we take that 420 and divide by 365, we get that this is 1.15 years. So that is our margin of error. So we do plus or minus 1.15. And what type of interval does that give us? So we would subtract the 1.15 and add the 1.15. So when we subtract it, we get a lower bound of 4.05. And when we add to the mean, we get an upper bound of 6.35. Now, the wording. The wording is the fill in the blank part. On Friday, we discussed, every time we just fill in the blank. We are blank % confident that the true mean blank, this is where we tell what we're finding the mean of, is between or lies between blank and blank. And then we need a unit. Okay, in this particular problem, we have a 95% confident interval, so 95 goes here. Mean of what? This is the mean lifetime of some tropical fish. And you could actually put in the specific type of fish. And that lifespan goes from lower bound of 4 years to that upper bound of 6.53, and the unit is years. Okay, now number 2 is a better problem because we do have to work more of it. So, number 1 warmed us up. Let's take a look at number 2. Every week a website displays the average price of a gallon of regular gasoline nationwide. This is based on a random poll. This is good that it's random. And we have 80 gas stations. So N is 80. Suppose that the average price was $2.94, so X bar is $2.94. And historically, the standard deviation of a gallon of gas, so the standard deviation of the population, is 8.3 cents. So I have this in dollars, so I'll go ahead and convert that to 0.083. We have to work with the same unit. Part A, what is a 90% confidence interval for the price of a gallon of gasoline nationwide? So, once again, we have 90%, 0.90. And so that would leave 0.05 and 0.05. So this upper bound is the z-score that is associated with a probability of 0.95. Everybody pull out those charts. Look for the closest thing to a probability of 0.95. That's on the inside of the chart. Read back out and find the associated z-score.
I'm gonna have to go with what are we looking for?
The z-score that is associated with a probability of 0.95. 1.645. That is correct. Okay, so in this case, Z star is 1.645. Okay, take a look at your chart and see if that makes sense to you.
Where did you get the 90%?
The question.
I don't know how we got that.
How do you find out?
Okay. I can't open it up because I no longer have access to my Google Drive. Actually, wait a second. I think just the other day I transferred all this to my desktop.
Find that number.
Okay.
0.9
No, this is all my old stuff.
down to 5. 0.8289.
I do not have access to it currently. Okay. So what you have to look for is the closest thing to 0.95 inside the chart. So if we look right here, it is actually right in between
Oh, we're looking at the numbers and then we're going to
1.64 and 1.65. 1.64 and 1.65. It's exactly halfway between those two. That's why we made it 1.645. Okay, so that's our Z star. So now let's refresh ourselves with this formula. It is X bar plus or minus Z star times sigma over square root of n. Now, X bar is the mean, and it tells us here that the average price was $2.94. So $2.94 goes here. Plus or minus Z star, that's the Z score associated with the confidence interval. And we just determined that that was 1.645. Sigma is the standard deviation of the population, and we were given that as 8.3 cents. And then N is the number of observations in the sample. And in this case, we have 80, so this would be the square root of 80. Okay, so what we're gonna calculate first is the margin of error. So you're just gonna do this part. First, we're gonna calculate the margin of error. And you're gonna want your calculators for that. Okay, quick timeout. I mentioned this in every other class. Fairly soon you'll be turning in your textbooks and you'll be turning in any calculators that you have checked out from Stars Mill High School. If you checked out a calculator from Stars Mill High School and you have lost the calculator, that calculator is $110 for us to replace it. So that is your fee for the calculator. Or if you can find a better deal, which you very well could, you would have to purchase one. To receive credit, it would have to be a new calculator in a box with the receipt. Reason being, we have had students that have lost theirs and then stolen another person's personal calculator and tried to turn it in as a new one. And so that's why it has to be new in a box with a receipt. That way we can be assured we're not going to be in possession of stolen goods. Yes, sir.
Alright, for back to math,
Yes.
the 1.645
Yes.
on here is in between 1.64 and 1.65.
Uh-huh.
So do I just put both numbers at the end?
No. So it's halfway in between 1.640 and 1.650. So because it's halfway in between those, if we just add a 5 at the end of the 4, it puts us halfway in between.
Alright. Thank you.
You're welcome. Okay. So, to the nearest thousandth, did you get 15 thousandths?
Yes.
Okay. So the margin of error is 15 thousandths. And when we add and subtract that number from our mean, we're going to get a lower bound of 2.925 and an upper bound of 2.955. Okay, so how would we interpret that?
Wait,
Yes.
what is the standard deviation 0.083 again?
Okay, so because we were in dollars here,
Okay.
we had to take the cents and change it into the same units. Okay? So now we're filling in the blanks. We are what percent confident? What confidence interval did we have? 90. That the true mean, what are we looking at this time? This time we're looking at the price of a gallon of regular gas. And that price is between the lower bound, 2.925, and the upper bound, 2.955, and my unit is dollars. So we're just filling in the blanks. Confidence level, what we're finding the mean of, and that confidence interval. Okay, let me come see where you have written this one down.
No.
Someone play.
No. We just.
Okay, most of you did. Some of you started to move when I got up to walk around.
Yes, that was me.
You just ratted yourself out, didn't you?
They don't know who I am. They don't know who
Okay.
I am.
Alright, so it's the same general thing.
It's not.
But problems are asking slightly different things. Sometimes they may just refer to the margin of error part. Sometimes we don't have to do the entire calculation. And then sometimes we have to do even more. So we just need to read and determine what the problem is asking and then decide where to go to from there. Okay, so let's take a look at number 3. Actually, let's make number 3 a you try.
Oh, whoa.
Okay, so we're gonna leave number 2 up and we'll let number 3 be a you try. If you need some help, if you get stuck, let me know. Okay, that paper was given out on Friday. You can check in the bin to see if there's any more.
Just no reason. Putting this in the class.
Yeah, that looks good. Okay, this one's actually easier because they gave us the lower and the upper bound. These are just halfway in between. So all you have to do is put the average of these two halfway in between, and then subtract, and that'll give you the margin of error. So we actually don't even have to use the whole formula. We actually don't have enough information. So that's why we have to take a different approach on that one.
That doesn't seem like a good idea.
Can you check what I have so far?
Now let me grab my answer key.
I can make this.
I just go to the blank.
Okay.
Is this the right Z-score?
Okay. Wait, that's
I don't understand how to do that.
What is this one?
Oh, yeah.
Really, really
1.75. Okay. How do you
Hey,
find
Miss
that?
Willoughby. How much numbers will I use again?
No,
Okay,
the summer
so
is.
if this is 92,
We
this
live
is
in
8.
Oh, so I should be four.
So 0.04.
What's the reason?
I don't know how to do
This
that.
side of it.
Okay, but you don't have to do this side, but you have to have this side, because this Z-score is this plus that. So
we have
4
a
plus 92 is 0.96.
It's like.
So stratifying is just saying 0.96, which is that. And then what's the Z-score that goes on?
Let's just say more than my own. I would take credit for that. I'd say like this hand and this hand and then multiply it by style.
That's
Just say gone and buried. I don't know.
Gone and buried.
Exactly.
forgive and
So, for some reason, you add. We gotta do like a.
tiny little couch.
That gun peppermint blanket.
Yeah. Then you add the middle thing.
Yeah, just
Then you get 36.
Gotcha.
that'd be cool.
I have them in math class. It's a little bit math related.
Are you done with number 3?
No.
No, you're just getting started.
Miss Willoughby, that's the standard deviation.
How did you get 2
Yes,
points?
that is the standard deviation of a population.
We're so silly. How do we get the standard deviation?
It's given to you in the problem.
Which it is,
Right, I feel like
I don't know, is it 100?
Eight. This plus this at a Z-score that is probability. Every time you look at this, what's left?
Willoughby, I'm doing good.
8.
divided by 2. Add those together. Every time.
Every time, wait, so every time you have this?
Every time you add it, those two are what you need to get to
Who was the
that.
life of the party? Who was the
Now,
life of the
Andrew
party?
has already noticed that .96 is really close.
It was Nick Palmer.
That's what I just
So
said.
it was
Yeah, I remember.
1.75.
He was fun.
Yes,
Yes, I do. He goes, Kylie.
So now we gotta go use that formula.
Kylie, here's Doggo.
Yeah.
I remember it all.
The same thing.
Okay, so
Not
the
me.
mean,
Belief
it
is.
tells us right.
Yeah, right, whatever.
Average battery is that, so that's your mean.
No.
Z star is this.
Belief. Here's the
Standard
But
deviation
he got a little
is
side
just this simple. The standard
No.
deviation is this. And that number of observations is 100. Punch this part in your calculator
It
first.
is been on the golden side. Oh, that is very true. Not, it turned back side. That's what I'm saying. This is the golden side, not black.
Alright, those of you that are finished, check.
Check, Cliff. You got those right.
Hold on, I almost finished. I got it set up. 2.9 plus or minus 1.75. Parentheses. What time is it?
I didn't.
What'd you say?
Well, we're about to use it real quick, but you're not gonna.
It's best to use the same math questions over and over again. Understand that.
I got 11.46.
You have to calculate.
When I swapped it out, I messed up.
I looked
A little bit messed up. I switched these two. Why did I do that?
I don't know. You put the standard deviation where the mean goes.
Alright, stupid.
I just haven't had enough practice yet.
That is very good. Is there a, study guide?
Actually increase the volume instead of.
Z star.
Oh, no.
Well, actually, I
No,
can't,
I had an extra
I can't get physics out of it.
That would have been.
But with that.
Oh, okay.
When you are, and then you pull back this and you
Alright.
say.
From what?
Oh, I get it.
Did you
Like,
really?
it was 50 questions, and he said he was only gonna count 25.
Alright, now, guys, when I am looking on the chart for .96, it is very close to .9599. It is 1/10,000, easy for me to say, away. So I just use this score exactly. I don't need to put a 5 on the end of it, because it's really close. Now, if you did put a 5 at the end of it, your answer's going to be really close, and I probably wouldn't count off. But there's no need for the extra 5 here. It's not halfway in between two. Okay, and then we just add and subtract what we find that margin of error to be from the mean, and then plug into, fill in the blanks.
What if I put like a 2?
Oh, I keep saying fill in the blanks, but on the test, you have to come up with all the words. The blue words are never going to change. The pink parts are what's going to change. So, I don't actually give you that statement. You have to come up with it.
Really?
Yes, Eli.
What do you add to the key?
Okay, so because the confidence interval was 92%, then we want to have an area under the curve of .92 where the mean can fall. But that leaves 8% for my tails. So this tail would have to be 4 and this one 4. So this upper bound, which is what our Z star is, that upper bound is going to be the 4 plus the 92, which is where the .96 comes from. Okay. Now, the next one. Read number 4.
Who writes these things? Margin of error is 2%.
It's got to be.
Everybody write that down. 98 minus 100 is?
You mean 100 minus 98?
Yes.
No.
Well,
Well, they're 98%
No.
confident, then there's 2% they're wrong.
Got it.
Okay, now, on this one, they give us the confidence interval. They say, hey, here it is. This interval represents a 98% confidence interval. So, when we do confidence interval, it is the mean plus or minus the margin of error. Well, the mean would be halfway in between, wouldn't it? So what is halfway in between? Add them up, divide by 2. 109.1. So to find the margin of error, the easiest way to do it is to take that upper bound and subtract the mean. 115.4 minus the mean is 6.3 pages. Because that margin of error is the part we go up and down from the mean.
How do we say it in words?
This one,
Yeah.
I would just say the margin of error is 6.3 pages.
Alright.
Yep. Okay. I guess if we're truly explaining margin of error is the acceptable range from the average. What do we find acceptable? Because in reality, we're always going to have to allow room for error.
Always.
Yeah. Unfortunately, none of us are perfect. That's right.
Mess something up.
Immediately, upon birth, we have messed something up. Okay. So, let's take a look at number 6. I know I'm skipping some. I'm doing it on purpose. All right. Number 6. Number 6 is giving us a data set. But it asks us first to determine if there's an outlier. Well, one number looks obvious. Another number looks maybe. We have 2 ways of finding outliers. And I would use outside of 3 standard deviations of the mean. So you're going to work this problem 2 ways. Luckily, you have technology. And so what you're going to first do is enter all the data and run a 1 variable stats so that you can determine if there is an outlier.
There's only one. I believe so.
Sometimes there's multiple, but this one just does have 1.
19.
Where you at?
Yes, go on.
Now, 19 looks like it could be.
But it's
Okay.
85.
So-
Definitely.
Alright, I'm asking you to be precise, and I'm also giving you an opportunity to practice using your calculator because during a testing situation, I will not tell you what buttons to push, and I will not tell you what symbols mean.
Second.
I'm testing whether you understand that by the time we get to a test. So make sure
Enter.
you can operate your
Stat
technology.
enter, guys.
Were there no extra pages over there?
You just click the delete button all the way through.
No, you don't. Missed it.
I did both.
It's clear. You delete.
No, if you hit clear, it erases. If you click delete, it only. I just did it. Tell me that's wrong.
It's wrong, clear.
That's not.
So if you want to clear something, don't you hit clear instead of delete?
If you want a whole column to go away, you go up to the top and hit clear. If you want one piece of data to go away,
You hit delete.
you arrow over the top of that and hit delete. Correct.
Question mark?
So I was right, basically.
No, I was
Cole
right.
was definitely right.
There was probably a little bit of right in both your answers.
No,
Cole was the
no.
most efficient.
I wasn't necessarily.
I said you click delete and he said you click clear to get rid of the numbers. Therefore, I am incorrect.
So was I, though.
No, not at all.
How you figure?
They have a number, like, they have a number. Yeah, ran out.
Is the test gonna be multiple choice?
No.
Do you want us? Never mind.
Alright, what are we looking for after we plug them all in?
I'm gonna fail so hard.
Me too.
Like single
What do I do
digits.
now that I got all of it? What are we looking for?
I
I
don't even
can't
know
afford
how
that
to do
just
that.
for.
Very wrong.
Did you find a calculator?
I might have accidentally put one in.
I do have a couple extra hanging out on my desk. Let me see what your number is.
Oh,
Yours is 0826. Let's see. It's not looking good, Justin.
now. Calculate.
I did have one student that had two, but he doesn't sit in here.
Better not put
Wait, was this it? 'Cause I found that one.
This one was on your desk.
Why must go quit?
Because I'm not.
Are you going to?
It's probably the only.
Chase Sands had two. Do you ever
There's
sit
like so
in
many
there?
choices.
Chase Sands.
No, I don't.
I like
It's a
that
hobby I'm
guy.
trying to pursue.
I can ask her today. Is he still there?
He had his and one more, and I don't know that.
Like shaking.
It's a clue.
This will be, I can't wait for you to get, people asking for extra credit. I forgot, you said we're not giving the extra credit.
I'm a little concerned about this test. This class has done the best of all my classes.
Oh, dear Lord,
If
that's
we're
not
doing
good.
the best.
Yeah, that's not
It's
good.
not good.
That's not good.
You're lying through your teeth.
Why would you
Maybe
make
we
it
should
hard
do
for
it.
us then?
Maybe we should just do an activity.
Oh no, it's totally
to the
not
test.
hard, but I have plenty of people that I predict will not pass because
Well, you got an
But you-
outlier,
they
right?
want
give
them
it-
to pass.
I'm not gonna lower the bar so that really lazy people will
That's
be okay.
true, but
They can go to a different school. if
What
that's they
about
need.
kind of?
Miss Willoughby, why don't we do an activity instead of a test?
Sure.
Let's make another turkey.
Like we did
Then-
the championship.
Then the lazy people will ride the coattails of the hardworking people. That's not right either.
Well, if we make everybody make a turkey again, then
we need like a
Copy a
good old turkey.
Conclusion, turkey solves
What
everything.
about a flower since it's almost summer?
Alright, so we have two means. With all the data, we have 28.75, and when you remove the outlier, you get 27.31.
Do we have to
Okay,
remove
so,
it?
so I have them both worked out here, and let's take a look now. The first thing you had to do for either one of them was to find the z-score associated with a 96% confidence interval. So what we're looking for on our chart is a probability of 0.98. Now that one is halfway in between 2.05 and 2.06. So you could write z star as 2.055. So it's x bar plus or minus z star, the standard deviation over the number of observations. If I delete the outlier, my number of observations goes from 40 to 39. Now, how did I know that 85 was an outlier? Well, first of all, it looks different. That's not good enough. The fact that it looks different is not defining it as an outlier. It is greater than 3 standard deviations from the mean. 85 is greater than the mean plus 3 standard deviations. It is written here on the board. 28.75 plus 3 times 9.65. 85 is bigger than that. So because it lies outside of 3 standard deviations of the mean, it is defined as an outlier. So if we delete that outlier, this is our data. If we do not delete our outlier, this is our data. We should delete our outlier. So this is the more accurate result.
But maybe there's always that.
This is skewing our data and would give us a confidence interval that didn't accurately reflect the entire population.
So we just cut out the weird people?
Yep,
That's not very nice.
that's right. It is effective though.
Yeah.
Okay, on a test, I more than likely wouldn't give you 40 pieces of data to enter because that does open up the opportunity to have some issues. I'd probably give you a much smaller sample, but what's the issue with a smaller sample? To have an effective sample, N should be at least, what, 30. So if I give you a smaller sample, then we have some issues that we're not going to address this year. Okay, the last thing we're going to talk about is, I think this is number 9 in your, so it's the last problem.
Did we get a study guide?
Yes.
Sweet.
All right, so margin of error. Number 9 is just dealing with margin of error. That is the only part of the formula we will look at for number 9. Number 9 actually gives us a margin of error. It says 0.3 is acceptable. Number 8, thank you. It's the last problem, whatever last problem. Thank you. All right, we can find Z star. It's a 99% confidence interval, so this would be 0.995. And the Z-score that correlates to 0.995. Now, if you pull your chart out and look for 0.995, it looks like we could have even added a 5 right here and been good. I didn't, but you could. Standard deviation is given, and N is what we're trying to solve for. So, if we're given 0.3 degrees Fahrenheit, that's our acceptable margin of error for this refrigerator. The standard deviation on that temperature is 1.2 degrees, and that 99% confidence level led us to a Z-score of 2.57. So to solve for N, we'd have to get it out of the denominator and then divide by the 0.3. And then we square both sides. So you can punch into your calculator 2.57 times 1.2 divided by 0.3 and then square that. And we get that we would need to sample 105.6 refrigerators. That's not a possibility.
We don't want to.
So we would have to sample 106 refrigerators. If we drop down, we are no longer at a 99% confidence interval.
Can't have
Wouldn't work.
a refrigerator.
Okay, so I'm going to give you a second sheet. This second sheet is the one I'd like you to do tonight so that you actually get good practice with confidence intervals on your own.